All right, so I want to get deeper than that, but I won't. I am just going to go ahead and get into the experiment now. So for us, we're going to have two metal plates. One plate is going to be grounded. Whenever you see this symbol, it represents 0 volts, or at least it's appreciably 0 compared to a plus or minus 500 volts, okay? We're going to send an oil droplet through this orifice. The oil droplet will fall under its weight, F sub G, and that's just mg, the mass of the oil droplet. And it's going to experience a resistive force, and I believe it's KVF. So this is a resistive force, okay? So it's falling through a fluid, and that fluid happens to be air, okay? And so we can do some calculations here. We're going to use Newton's second law. Isn't that powerful? Newton's second law in the y direction is going to have to equal to 0. We don't want it when this thing is accelerating. We only want this oil droplet when it is moving at terminal velocity. So here we go. We have two forces acting. So the summation of forces and their vectors. We have y, it's going down, so this is a negative mg. So we don't need to put any special notation because we've placed a negative sign in, plus kvf. And we know that this is just equal to 0. All right. So with this formula, well, I can just say, therefore, K is equal to mg over VF. So we're going to use this to get rid of the K. So we're gonna do something here in a second. Under this scenario, our voltage on the top plate happens to be 0. I mentioned that last, so it's actually 0. But when we put a voltage, either a plus or minus, on the top plate, then this object can rise or fall, or I mean, it can accelerate downward or upward. So we want it when it's accelerating upward. If it's accelerating upward, this is going to be a force sub Q. This is just going to be the charge times the electric field. The charge on the oil droplet times the electric field. You still have your weight, mg, and now you have a resistive force acting against the motion of the oil droplet. So this is going to be kv rise. So now we can do the same analysis. When we do the same analysis, we end up with the net force equaling to Q times E minus KVR minus mg. All of this, again, is going to equal to 0 because we don't want it accelerating. We're going to substitute the value for K into this equation. And when we substitute it in, we could solve for Q. As long as we know everything else, we need to calculate the mass, we need to calculate the radius, we need to know the electric field and all of that good stuff. All right. So let me go ahead and get this experiment. And so in this experiment, I'm going to go ahead and take this over to video physics. I was going to show it to you, but I might as well take it over to video physics. Okay, so if I play this, you'll see this big kind of oil droplet here. It's going to fall, and then when I switch the voltage, it'll rise. So we're going to track this oil droplet, okay? And we're going to use our tracking feature here. Before we continue, I want to bring over our calculator, because there are quite a few things that we need to, well, I say quite a few things, but I want to bring over our calculator. It's actually not a whole bunch we have to do, because I do a lot of the pre-work for you. Stuff that you could easily find on your own. It's not that you can't do it, because I used to have the students do all of it. I know you can do it. So we have our average velocities. We're going to bring our average velocities in. We have the radius here. So the radius is based on some constant B, atmospheric pressure, which we need to find out today, eta, which is the viscosity, fall speed, which is going to come from our average velocities here. Gravity, it's in this area, it's about 9.799. I'll look that up again for today. And we'll have mass. The mass is going, well, I'm not done with that, sorry. Density of oil, this is just mineral oil. It's a laxative. So it's 886 kilograms per meter squared, cubed, not squared. And so we just do some calculations here based on these things. Now, this is not calculated because we don't have our fall speed. And that's what we need. If I move right on over, you'll see that the radius is going to be calculated. So it's a long formula, but it's okay if you guys don't have to do it. So again, we have density, we have radius, and we're going to calculate our mass here. And then we're going to finally calculate the charge on this oil droplet and the number of charges that's actually on this oil droplet. So that's what we're about to go through in the next video.